Assalamu alaikum. I hope all of you will be all fine. So, as a further practice, I have also recorded the video for DOF or degree of freedom or mobility is equal to 4 and links number of links up to 11 number of links are and up to hexagonal order. So, student must be well conversant with this procedure and they should not find any difficulty in number synthesis for higher degrees of freedom or mobility. So as we can observe that here that for DOF M is equal to 4, so assume DOF is equal to 4, so that means the mobility or DOF is even, so that means the number of links must be odd because the DOF and number of links are actually vice versa, means if DOF is odd then link must be even, and if links are odd then DOF must be even. So again we can use equation 2.4a and 2.6 on page number 44. So the same reference which I have given in other videos, I will again be showing the same reference here, 2.4a, this equation, and this equation is 2.6. so these are actually two deciding equations. So in this way these references are given here for, and the same numbering has been used as in the textbook. So the first equation is this and the second equation 2.6 is this. So for DOF M is equal to 4, equation 2.6 will give you L minus 3 minus 4 is equal to this, and L minus 7. In a similar manner we can observe L minus 7 is equal to T plus 2Q plus 3P plus 4H. So this equation has been numbered 1. As we can observe that this is the deciding equation to start from, and here we can observe that the starting number of link cannot be less than 7, because if for example number of links are, for example, because DOF is 4, link number of link must be odd, so that can be 5 or 3. So if for example the total number of links are 5, so that means 5 minus 7 is equal to minus 2. So that means the sum of these links is actually giving a negative number, which is impossible practically or physically. So that means we will be starting from the minimum number of links, which is L is equal to 7. So again the procedure has been repeated here, that L can never be less than 7, because such as for example 5 or 3 or even 1, because that will require a negative number of links on the right hand side here, and which is impossible. So we can observe that for L is equal to 7, 7 minus 7 0. So here as we can observe that T plus 2Q plus 3P plus 4H is equal to 0. So that means none of the links of ternary, quaternary, pentagonal or hexagonal can obtain or assume or adopt other value than 0. So that means all T, P, Q, H are 0. So that means, and now we will be using the second equation 2.4a to determine the binary links. So from that equation we can observe the total number of links are 7, so that means all are binary links. So the first combination for DOF M is equal to 4 is equal to B7, which means the minimum all must be binary links for L is equal to 7 and M is equal to 4 case. So the first combination for 4 degree of 4 degree of freedom or mobility is equal to all the binary links which can be 7 in number, which must be 7 in number, and all ternary, quaternary, pentagon, hexagon link will be 0. So there is only one combination possible. So this is also, we can say, this is the only one isomer for 4 DOF. Now we repeat for L is equal to 9, means the next value after 7 can be L is equal to 9. It means total number of links can be 9. So this is odd, and for DOF for M is equal to 4, which is even. So again equation 2.6 is given like this. So we can observe that 9 minus 7 is equal to 2. So T plus 2Q plus 3P plus 4H is equal to 2, and this is the deciding equation. Starting equation 2 is equal to T plus 2Q plus 3P plus 4H. So as we can observe that in this equation we can observe that H can be 0 or 1, but in this equation we can observe that if H is equal to 1, that means 2 will be equal to T plus 2Q plus 3P plus 4. So this 4 will be subtracted on the left hand side from 2. So 2 minus 4 will be giving minus 2. So the sum of T plus 2Q plus 3P will be giving minus 2, which is impossible practically. So that means for L is equal to 9, each cannot, hexagonal link cannot be 1, that can only be 0. So that means H is must be 0. So if we proceed towards pentagonal link, again pentagonal link can also be 0, because if P is equal to 1, that means 2 is equal to T plus 2Q plus 3. So which is also impossible, because that will give 2 minus 3 minus 1, so that will also give negative number. So both P and H must be 0. Although the procedure has been explained many times in previous videos, so I am again and again repeating the same wording so the student memorize and don't forget. So actually the approach is this. So as we can observe, so P and H all are 0. So T plus 2Q is equal to 2. So here we can observe that Q can assume 0 or 1 value only. Again Q cannot be greater than 1, because if for example Q is equal to 2, so that will be T plus 4, and when this 4 will be subtracted from 2, 2 minus 4, so T will become negative 2, which is impossible. So Q can only be 0 or 1. So if Q is equal to 0, we can observe that T is equal to 2, and the other equation 2.4a will give the number of binary links. So total number of links are 9. So 9 minus 2 with binary link will be 7, though the first combination for M is equal to 4 and L is equal to 9 will be equal to 7 binary links, 2 ternary links, and all quaternary, pentagonal and hexagonal links will be all 0. So the first combination for L is equal to 9 has been obtained. So now we will be testing the other value, means Q0 has been tested, and now Q will be equal to 1. So if Q is equal to 1, the equation will be giving that T 2 minus 2, so T will be equal to 0. So the other equation will be giving as we can observe that total number of links are 9, and there is only one quaternary link, and all ternary and pentagon hexagonal links are 0. So in this way B will be equal to 9 minus 1, which is equal to 8. So the second combination for M is equal to 4 and L is equal to 9 is 8 binary links, 1 quaternary link, so all ternary, pentagonal, hexagonal links are 0. So in this way for M is equal to 4 and L is equal to 9, there are only two possible combination or sets. So now the next value, if the number of links are 11, the so what will be the procedure? So if L is equal to 11, for DOF is equal to 4. So we will be starting again from the same equation. We can observe that L minus 3 minus 4 and L minus 7 in a similar manner, and here the result is this 4, equation number 4, which is equal to 4 is equal to T plus 2Q plus 3P plus 4H. So here again we observe that H can only adopt 0 and 1 value and cannot be greater than 1, because if for example H is equal to 2, that means 4 multiplied by 2, that will be 8. So 4 will be equal to T plus 2Q plus 3P plus 8. So this 8 will be subtracted from 4 on the left hand side, so this will be giving negative 4. So that means the sum of the T plus 2Q plus 3P will be equal to negative 4, which is practically impossible, that neither the sum of any types of links gives the negative number. So that means that is practically impossible. So again I have explained the same statement. So each can assume or adopt only 0 or 1 value. So we can observe that for h is equal to 0, the equation will be reduced to 4 is equal to T plus 2Q plus 3P. So now again for h is equal to 0, we will be testing P. So P will be a 0 or 1 here, because if P cannot be greater than 1, because for example if P is equal to 2, so that means 3 multiplied by 2 will be equal to 6. So T plus 2Q plus 6 is equal to 4. So that 6 will be subtracted from 4 on the left hand side. So that will be giving T plus 2Q is equal to minus 2, which is practically impossible, because the sum of the ternary and quaternary link is giving the negative results, which is practically impossible. So that means P can be 0 or 1. So if P is equal to for example 0, so that means T plus 2Q is equal to 4. And now again we will be starting that Q can assume here 0 or 1 or 2 values, and cannot be greater than 2 in a similar manner as I have already explained. So if Q is equal to 0, in this equation number 4, we can observe that T will come out to be equal to 4. So the other equation will be giving that total number of links are 11. So ternary links are 4. So 11 minus 4 binary links will be 7. So the first combination for L is equal to 11 and M is equal to 4 will be 7 binary links, 4 ternary links, and quaternary, pentagonal and hexagonal link all will be 0. So first combination has obtained. Now we will be testing the other value, second value, that is 1. So if Q is equal to 1, we can observe that T plus 2, that means T is equal to 4 minus 2, which is equal to 2. So ternary links are 2 and quaternary link is 1. So the other equation 2.4a will be giving the number of binary links. So 11 minus 3 will be equal to 8. So there will be 8 binary links. So the second combination for L is equal to 11 and M is equal to 4 will be giving B is equal to 8 binary links, 2 ternary links, and 1 quaternary link, and pentagonal hexagonal links will all be 0. Again the third value that was listed, that was Q is equal to 2. So if Q is equal to 2, we can observe here that T will be equal to 0, because 4 is equal to T plus 4. So 4 minus 4 will be equal to 0. So the other equation will be giving the number of binary links. So as we can observe, there are 2 quaternary links. So 11 minus 2 will be equal to B is equal to 9. So the third combination for L11 and M4 is equal to 9 binary links, 2 quaternary links, and ternary, pentagonal or hexagonal link must be 0 in that combination. So now as the q all values for the quaternary link have been tested out, so we will be moving backwards to the pentagonal link, because all these values of quaternary link were tested for p is equal to 0. So the other value for p is equal to was 1. So p0 has been tested out for q is equal to 0 or 1 or 2, and now the other value p will be tested in this equation number 5. So for p is equal to 1, that equation number 5 that gives us 4 is equal to t plus 2q plus 3p, and or 4 is equal to t plus 2q plus 3, or t plus 2q is equal to 1. Again the procedure will be same, that starting from the highest order link, which is quaternary link in this equation. So if we observe that in this equation, because t plus 2q is equal to 1, so q can't even be 1, q must be 0, because if q is equal to 1, so that will give t is equal to 1 minus 2 on this side, so t will become negative, which is impossible. So that means q can only be 0, so that means t is equal to 1. So the other equation is giving that 11 minus 2, because one is the pentagonal link and one is the ternary link. So there are two other types of links. So 11 minus 2 is equal to 9, 9 binary links. So the fourth combination for L is equal to 10, M is equal to 3 is equal to 9 binary links, 1 ternary link and 1 pentagonal link, and quaternary and hexagonal links are 0 in this combination. Remember that this number of combination, fourth combination or third combination is not specific, it is random. So you can say any combination to be four number, or that can be in any order. So this order is not very important of these combinations, so I have randomly listed them. So now the last set remains for h is equal to 0, because h is equal to 1, because there were two values for h is equal to a 0 has been tested out, and now we will be testing h is equal to 1. So h is equal to 1, the equation number 4 that gives 4 is equal to t plus 2q plus 3p plus 4h. So that is giving you simply that we can observe that t plus 2q plus 3p will be equal to 4 minus 4, which will be equal to 0. So that means the sum of t plus 2q plus 3p will be equal to 0. So if even if any of the link assumes the lowest value means 1, so the there cannot be 0 on the left hand side or right hand side. So that means all t, q and p must be 0. So that means t, q, p must be 0, and the other equation is given the number of binary links. So there is one hexagonal link, so 11 minus 1, so binary links are 10. So the fifth combination for L is equal to 11 and M is equal to 4, which is equal to B10 hexagonal 1 link, and T, Q, P all be 0. So all link combination found for 4 DOF and up to 11 links and to hexagonal order found out this way. So a tabular approach for easy and fast calculation for L is equal to 11 and M is equal to 4 is shown below. Refer the page 45 of Design of Machinery book 6th edition. A tabular approach for L is equal to 11 and M is equal to 4. So here the tabular approach has also been used for 4 DOF. So as we can observe, the equation was 2.6 equation was L minus 3 minus M. M was 4, so minus 3 minus 4, L minus 7. So this is equal to T plus 2Q plus 3P plus 4H is equal to, so 11 minus 7 will be equal to 4, and the other equation which actually connects the total number of different types of links by b plus t plus q plus p plus h is equal to 11. So in a similar manner we can, if we observe the first equation, so starting from the highest number of link which is hexagonal and its lowest count or lowest number 0 or 1, so it can obtain adopt or assume two values 0 and 1 cannot be greater than 1, because if for example h is equal to 2, so that means 4 multiplied by 2. So when this 8 will be subtracted from this 4 on the right hand side, 4 minus 8 will be equal to minus 4, so that will be meaning that t plus 2q plus 3p is equal to minus 4, which is practically impossible, because that depicts that the sum of a certain number of links is giving the negative sum, which is practically and physically impossible. So that means h can assume or adopt only 0 and 1 value. So if for example h is equal to 1, because it has only one set, because if h is equal to 1, so we can observe that here will be t plus 2q plus 3p is plus 4 is equal to 4. So 4 minus 4 will be equal to 0, so t plus 2q plus 3p will be equal to 0. That means that t, q and p all must be 0. So this lower equation will give that hexagonal will be 1, so 11 minus 1 will be equal to 10, so binary link will be 10 and hexagonal link will be 1, and ternary, quaternary, pentagonal link will all be 0. So in this way first set has been obtained for hexagonal value 1. So the other value for the hexagonal link is 0, means there cannot be any hexagonal link in the linkage. So if h is equal to 0, the equation is further reduced to t plus 2q plus 3p is equal to 4, and the lower equation becomes b plus t plus q plus p is equal to 11. And now we will be repeating the same procedure. The highest order number of link here is the pentagonal link, so on the right hand side there is 4. So if we can observe that p can assume only these values, p can be 0 or p can be 1 in this equation, this upper equation. Remember, this upper equation will be used. So cannot be greater than 1, because if for example p is equal to 2, so that means 3 multiplied by 2 will be 6, so this 6 will be subtracted from 4 on the right hand side, so that will be giving 4 minus 6, which is equal to minus 2. So t plus 2q will be equal to minus 2, which is practically impossible, because the sum of the ternary and quaternary link is giving the negative sum, which is practically physically impossible. So that means p can assume or adopt only these two values 0 and 1. So in this way, as we can observe that if for example p is equal to 0, so t plus 2q will be equal to 4, and the lower set of equation which actually connects the total number and types of links, which is equal to b plus t plus q is equal to 11. So here we will be observing the same procedure, t plus 2q is equal to 4, and q can in a similar manner, which I have explained many times, that assume these values only. Q can be 0, q can be 1, q can be 2 in this equation only. So cannot be greater than 2, as we can observe. So if q is equal to 0, we can observe t will be equal to 4, and the lower equation will be given 11 minus 4, that will be 7. So in this way this set has also been satisfied. 7 plus 4, which is 11, so 11 number of links have been satisfied. So other value, if q is equal to 1, so if q is equal to 1, so t will be equal to 4 minus 2, which is t will be equal to 2, and the lower equation will be giving 11 minus 3 will be equal to 8. So 8 binary links, 2 ternary links, and 1 quaternary link. So 8 plus 2 plus 1, so 11 links have been satisfied. And the third combination for q is equal to 2 will be equal to, if q is equal to 2, so that means t plus 4 is equal to 4, 4 minus 4 is equal to 0, so t will be 0. And the lower equation will be giving 11 minus 2 means quaternary link are 2, so that will be giving 9 binary links. So 9 binary links and 2 quaternary links, 9 plus 2 is equal to 11. So in this way this set has also been satisfied. Now we move towards the other value of p, which is equal to 1. So if p is equal to 1, this equation is reduced. T plus 2q plus 3 is equal to 4, 4 minus 3 is equal to 1, so t plus 2q is equal to 1. And the lower equation will become p plus b plus t plus q is equal to 10, because this one pentagonal will be subtracted from this 11, so 11 minus 1 will be equal to 10. So in this equation, as we can observe that here q must be 0, because even if q is equal to 1, that means t will be negative. So that means q is equal to 0, so ternary link will be 1 and quaternary link will be 0. And the lower equation will give the binary link. So that means 10 minus 1 ternary link, that will be giving 9 binary links. So in this way 9 binary links and 1 ternary link, so 9 minus 1 9 plus 1 and plus this pentagonal link, so 9 plus 1 plus 1, so 11 links have been satisfied. So 1 2 3 4, and this is the fifth set, so all fifth set for L is equal to 11 and M is equal to 4 have been satisfied. And here again a similar table has been made as in the book, that if there are for 4 DOF and up to 11 links, so if there are a total number of links 7, so they all must be binary links. And here again the same technique has been used for to check the validity of the linkage, that here n by 2 is equal to total number of links are 7, so the n by 2 is equal to 3.5. And the highest order link node, here the highest order link node is binary link, so it has 2 nodes, so 2 is less than 3.5, so this means this is a valid linkage. So in this manner, if there are total number of links 9 links for 4 DOF, so it has 2 sets. So in this set we can observe the highest order link is actually ternary links, which has 3 nodes, and the total number of links are 9, so its half is 4.5. so that means highest order link node 3 are less than the half count of the total number of links, so this is also a valid linkage. In the third row we can observe the highest order link is actually quaternary link, which has 4 nodes, and the half count of the total number of link is 4.5. so again 4 is less than 4.5, again this is a valid linkage. And now if L is equal to 11, we can observe that the highest order link here is the ternary link, which has 3 nodes and the half count is 5.5. so again this is also a valid linkage, because 3 is less than 5.5, so this is also a valid linkage. So if L is equal to 11 and there are 8 binary and 2 ternary and 1 quaternary links, so highest order link is quaternary link, which has 4 nodes and half count of the total number of link is 5.5, again 4 is less than 5.5, so again this is a valid linkage. And this set which shows that there are 9 binary links and 2 quaternary links, again the highest order link is quaternary, which has 4 nodes, and this is less than the half count of the number of links, so this is also a valid linkage. And this second last set, which is actually states that there are 9 binary links, 1 ternary link and 1 pentagonal link. Here we observe that the highest order link is pentagonal, which has 5 nodes, so 5 is also less than 5.5, so this is also a valid linkage. And this last link set, which says that there are 10 binary links and 1 hexagonal link. So here we can observe the highest order node is actually 6, so n is equal to 5.5, so 6 is greater than 5.5, means the highest order node are greater than the half count of the total number of links. So that means this is invalid according to the statement which is mentioned here on page number 48 of the book, that the highest order link in a linkage cannot have more node than n by 2, where n is the total number of links. So in this way, so in this way the validity of the linkage has also been explained. So this is an invalid set, but we must list here in the table whether valid or invalid. This is the practical procedure and connecting, but we will must and necessarily be mentioning all the link sets here which was practically obtained from number synthesis. So we will not be omitting any set, all will be listed here. So this is the further procedure, that whether the linkage is valid or invalid, so we will not be omitting any link set. So here uh, for linkage up to 11 links and 4 DOF has also been explained for the assistance of students and audience. So if you have any question, you can frankly meet and ask. And thank you, and assalamu alaikum, jazakallah, God bless you. Allah Hafiz.